All right, so question number 13, and they ask you to solve this equation using any method, right? Never pay attention to the second sentence because we don't have a denominator, right? So now what we're going to do again is the regular method, is just to make distribution, add the like terms, all right, and then see, isolate the p, right? So if I multiply first, it's going to be 2 times p, 2 times minus 5 minus 10 plus p squared. P times p is going to be p squared. P times 2 is going to be 2p and minus 10. So I just a regular distribution, all right? Now I'm gonna try to combine all the like terms. So the way we do it, usually we group the p's together and we group the numbers from the other side, right? So here you're going to be 2p plus p squared. So my intention again is to move this guy to the other side after the equal sign, right? So if I do that, this is going to be the p squared, sorry, it's going to be only minus 10 here, and I move the minus 10 to the other side, it's going to be plus 10. All right, now I'm going to do the same thing with the other ones, so I'm going to move them to the other side, so the p is here, all right? And if I do that, this I might need more space, so this will give me p squared moved to that side, it's going to be minus p squared. 2p moved to this side, it used to be positive, so it can be minus 2p. And finally I will get this expression, right? We notice here, if I combine the like terms, the 2p cancels out with minus 2p, p squared cancels out with p squared, so I will end up with 0p basically, alright, plus 0p squared. And the same thing will happen again, minus 10 plus 10, and that's going to give me again 0, alright. So let me write it in. So what is 0p times 0p squared, which is 0 again, right? So this is 0 and equals to 0. So we have these equations, sometimes the p disappears or the variable disappears, right? So what we do, all right, so usually we freak out here, and actually the solution is really simple. You look to this statement, the last statement over here, and you make a judgment, is it true statement or not true statement, true or false. So what do you think about 0? Is it equal to 0? Yes, it's true, right? True all the time. So we were saying that 0 equals to 0 is a true statement. So every time I end up with a true statement, this is going to imply directly that the solution, all right, will be equals to all real numbers. All right, all real numbers as well, we can notate it as capital R, which is, that's all real numbers, or we can as well equal sign to minus infinity to plus infinity if you rather have an interval notation. All right, so that's basically it. This is our solution over here. All right, there is nothing else to do. So now I'm going to discuss the other scenario. So let's suppose that after doing the calculation over here, I end up with a statement which is one side is going to give me 0, another side, let's suppose any other numbers, right? So let's suppose 1. So obviously here 0 is not equals to 1, right? So this will be a false statement. So what the meaning of false statement? All right, so that's the other side of these outcomes, right? So the meaning of false statement, it means that there is no solution. All right, and this would be the other possibility, right? So again, to resume this exercise, you solve it as usually you solve any equation, linear equation or quadratic equation. So if you and all the variables disappears and you end up with a statement, the statement should be a number equal to another number. So if the two numbers are equal to each other, then it's going to be a true statement, and the solution would be R real numbers. All right. If those two numbers are not equal to each other, example here, 0 is not equal to 1, so it would be a false statement, and the answer would be no solution. Okay, that's all.